Hey everybody, welcome back. Okay, so like I talked about last time, we're going to follow through the example on how to calculate the center of mass or volume, center, whatever, for a composite body. So what we have right here are three blocks. They're assembled. Your child was building something, and suddenly you're like, I need to do this. I need to do center body. And these are also huge blocks. That's 1.8 meters. That's as tall as me. So your child is playing with some amazing blocks. Actually, I'm taller than 1 meter. It's more like 2 meters, but I'm a little less than that. Well, who cares? Your child has some amazing blocks. Hopefully, this is made of foam. So, what we want to find is the center of volume of the assembly. Spoiler alert, somewhere in here. You're going to follow the steps for analysis. Okay. I get that we haven't had much experience with this yet. So if you don't want to try this on your own, you want to just watch the video and then maybe go back and try to do it by yourself, I won't judge you. But I'm going to still give you the 3 seconds to try it on your own. So 3, 2, 1. You have possibly paused, maybe not, and you're back now. So let's go through this. Okay, so we're going to break this up into A, B, and C. Where's my little pound? There it is. A, B, and C. C and A are both triangular. B is rectangular. We know where the centroid is for all three of those kinds of shapes. So first off, we're going to calculate the volume of each shape. Well, volume of A is a triangle, so 1/2 base times height times the width. It's 1.5 base, 1.8 high, 0.5 width. And that's the same for both of these blocks. So they have the same exact volume. Volume of the rectangle is 1/2 base times height. So it's 2.5 meters long times 1.8 meters times 0.5 meters. That's the thickness. So we've got all their volumes. And I probably need to calculate the total volume as well. And then I have this crazy table right here. And this is the table I was talking about. So you see we have whatever we're calculating, volume in this case, and then their moment arms from each particular axis, and then their volume times the moment arm for each of them. Okay. So you see the volumes here, and we also go ahead and do the sum for each of the, these aspects and this one. You don't need to do the sum for the moment arms. It's not necessary. Now, let's talk about this and where did it come from. Okay, so for section A, that is the triangular section right here. X bar is 1, Y bar is 0.25, and Z bar is 0.6. Okay. So where did this come from? Okay, where did it come from? Okay, let's talk about this and figure it out. So first off, the x1 is the distance from the y-axis. Okay, it's our distance from the y-axis. So that is 1. Now why is it 1? Well, first off, it has to be more than 0.5 because we have piece B here. And the second thing is, if you look in a table, what it will tell you is that the centroid of a triangular section happens at 1/3 or 2/3. It's 1/3 from this tip right here. And so 1/3 of 1.5 is 0.5. So 0.5 plus 0.5 gives me a bar of 1. Then y bar is the distance from the x-axis. Okay, it's the distance from the x-axis. Now, once again, we have to figure out where is that coming from. Well, it's simple because this is symmetric along that direction. And so I just have to go half the distance. It's going to be along this plane, dividing it in half. So 0.25, that's half the thickness. And then finally, z. What is that the distance from? It's the distance from the xy plane. The distance from the xy plane. What you can see in this case is 0.6 because it's 1/3 of 1.8. Section B is much simpler because it's just a rectangle. So it's half the width, half the length, so 0.25, and then half the height. Now if you're wondering, okay, what about this 1.25 right here? Anybody wondering about that? Because this is 2. It's because it's not 2. It's 2.5. Don't forget that. That's a big mistake a lot of people make, is that you're like, okay, I see the dimension, you go forward, and you completely forget that there was that little hidden section right there that we had to take into account in that dimension. be careful. And finally, the last one is the exact same thing, just slightly different orientation. Also be careful, you notice that this one right here is 3. That's the distance from the x-axis. Why is it so big? It's because we go 2.5 and then a third of 1.5. You got to make sure you're doing the entire distance, not just this one by itself, but where is it related to the origin. Okay, having all of that, you multiply these together and you sum them. And then we can just use our nice little equation because we already know what the sums are for both of these. We just plug in our numbers and we can solve. Easy peasy. That table is extremely helpful. It's a great way of note keeping. It's a great way of remembering exactly what steps you're supposed to take. It will keep you from making a whole bunch of mistakes. So use it. Use it to your advantage. But we're going to stop here for now. We'll do another problem next time. I hope this helps you. Practice this. Try some book problems if you need a little bit more, need a few more examples. If there's one you get stuck on, just email me and I'll make a video of it. Hope you have a wonderful day. I'll see you all later. Bye-bye.